Okay, so as promised, token stream is something, a separate facility that we need to be able to basically understand before moving forward with all of the rules for arithmetic expressions. So far, what we have is that we have a class named Lexer. Let me switch over to just blank ink over here. So we have Lexer, right, which has the constructor, right, the constructor here, but all it does is basically saves token stream stream object inside when it's constructed, right? And so far we have this start rule, which basically kicks things off, but we have the token stream, a separate class which has its own set of responsibilities. We're about to take a look at this, which basically stores a token index, which is pretty much just an integer data type. It also has string builder. It has this input, right? An input, which is the string builder, and it also has an array of tokens, which is simply an array of string objects. So these are the data that the token string stores internally. Of course, it has the constructor token stream constructor, right, method, and then it has some operations, and one of the operations primarily that we need to be able to understand first is this thing tokenize input, right? So this is the method that we need to understand first, and start rule we already know basically calls into this tokenized input in order to be able to get things started, right? So the Lexer basically uses a token stream as a helper object which internally handles user input and all that. So the Lexer right here does not directly store input. It basically says, the constructor of Lexer says, I will create new token stream and you will be responsible for holding the input text that the user typed in. Okay. So let's take a look at the constructor. The constructor of the token stream is not very sophisticated. All it says is, you give me the string builder, which is basically a dynamic string, and I get this dynamic string from you, and I will store it internally so that I have an instance of the string builder. Basically, I have object reference to the original input provided by the user, right? So this entire input will be kept. I actually got rid of it already, but the entire input is kept by the as a data attribute stored directly in the token string. All right. So the next thing, which is the longest, and it's not really terribly long, but it's the longest so far, is called tokenized input. So tokenized input is what we do early on in order to prepare input for our own understanding and doing some analysis. So what it does is this. What it does is basically it says for every character it appears, right? So input is a string builder is a named input. Has a length, right? A length of characters, right? So the string builder is basically just like a string, is basically like a dynamic string, which is basically a long sequence of characters. And we say for index of every character, let's do the following. Let's just take a look at basically say input, give us one character. So one character at a time, right? So basically inside this token stream object, we have the string builder, and basically we take a look at this string builder, and we look at all individual characters right there, and we use this local variable name index, right? Index, that basically visits every character, and we start with index 0, which gives us access to the first character, and we say that let's increment the index and run this entire loop, so this index will provide access to every single character inside this input, right? This thing is called input, and we will run our loop. And what we do, we basically extract each character, and we call it one char, right? One char basically is a little local variable that we use at runtime, where we store each character sequentially and try to analyze it. And we analyze it by saying, if it's a digit, do one thing, right? If it's a letter, then let's do a different thing. So why do we deal with letters like A, B, C, D, E, F? Because in the future, we may be thinking about adding variables to our desktop calculator. So X, Y, and Z could be used as variables, and we can assign them values and proceed like improving what the user can do with the calculator by introducing variables. So that's why alphabetical entries like A, B, C, D, E, F, and so forth are considered to be important to construction of this token stream that we're in the process of. Okay, then I say that the next thing for us to analyze would be actually to look at punctuation and white space, but I give special attention to parentheses, right? If we deal with parentheses, I would like to distinguish them as absolutely two separate tokens, and each parentheses has to be understood as one unique token, right? So we don't want to mix parentheses with any other punctuation characters like pluses and minuses, simply because parentheses are absolutely special to us, and they have on their own, they have a very special meaning. And therefore they need to be recognized by in the process of us constructing the token stream. The next thing that happens is that is there a white space? We also look at our one char, and we'd like to be able to deal with white space. And finally, we say whether it's a punctuation or not, and punctuation is one of the methods already added to the token stream, which basically demonstrates a method that you could have that says is punctuation. It's actually a static method which takes one character, uses the character helper class to check whether it's digit, letter, or white space, and otherwise returns true if it's a punctuation. So very simple approach over here, right? So and these are the different categories of tokens, right? So if we have some input, right? So if I basically add myself here, and so rewrite this like 1 minus 2 plus 3 minus 4 plus 5, something like that, right? By looking at my attempts to work with understanding of individual tokens inside input like this, what I do is that, of course, digits will give us the token such as this, right? Punctuation will give us a separate token such as this, another digit, another punctuation, another digit, another punctuation. Parentheses treated separately, right? So parentheses, both opening and closing parentheses, will be separate tokens. By the way, this was constructed in this method. And as you can see, it's a really low level work, because I I do look at each single individual character in this input. So what happens if this is a digit? What I do then, I say, well, you know what? It could be that what the user has typed was the whole sequence of digits, such as, 1, 2, 3. For example, and also I would like to be able to construct or create this application so we actually can use decimal points to specify fractional numbers. So anything that looks like this will be actually contributing to a single token. And if you look carefully, I say that, okay, so I look at the first digit, and then I say for as long as I have digit or a decimal point, which is this, then I simply advance my index inside this loop and deliberately say, well, you know what, let's move on and check whether I'm reaching the end of the input, just to be sure. Right, and I'm saying that let's take a look at the next character, and at the very beginning of this proceeding, actually at the end of this proceeding, I'm actually inserting a space. Right, so my attempt to tokenize input simply means, or simply translates to the idea. Let me rewrite this one more time. And I would just simplify it so that if the user types 1 plus 2 minus 3 without any spaces, in order, and actually let me also demonstrate this with parentheses, what I am going to do in this tokenized input loop at the top of it, and as I'm saying in at the top with my comment, right? So what I'm going to do is that I'm actually going to insert a space, right? So if I chose different color for this thing, I will be inserting space here, 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 and here, right? So basically, I will insert space and make sure that I tokenize this input in such way that, so now I will have separate token 1 plus 2 minus, and oh, by the way, there are also parentheses that we should not forget about, parentheses 2 minus 3 and another parentheses, and basically between these guys there will be spaces inserted, and they will be my demarcation of individual tokens. At the same time, if what was typed was not a single digit, right, but if someone typed 123.45, which represents fractional number, this would become the token, which would be the first token over here in this what I call token stream. So this is just a preparation step in this loop. So I feel free to insert spaces because String Builder is very happy to allow me to insert spaces wherever I decided to insert spaces, right? And then I say, now I'm ready to tokenize my input by simply using the split method. So I construct the new string, give it the copy of my string builder, construct brand new string, this time with spaces, and just say split, right? So once I split, I create an array of tokens, right? Which is basically an array of strings, right? So in my second step of this tokenize input method, what happens is that I basically create using split method of string to create an array of strings, right? So an array of string object references, and this time each one will be basically holding a string, a separate token, pointing to the separate token, which represent each token over here. So essentially, my split string split method populates this array of strings name tokens. And this is done very simply because I was wise enough to insert spaces where I thought would be a good place to have spaces. I have some spaces, so I say split, and split naturally returns an array of strings. And now this array of strings I will be interpreting as a stream of my tokens, or array of my individual tokens, which now should be completely meaningful to the rest of the program.